Because of the time frame, we're going to go ahead and get started.
Just get the boat and then let's do this.
All right. All right. So, your bell ringer today is to find the length of the segment posted up here on a coordinate plane on the board. Two different methods. You could use two different methods to get this answer. Somebody, raise your hand. Maybe one of them, Melissa.
Pythagorean theorem.
Okay, Pythagorean theorem. So we're going to go one at a time. Guys,
I said it first.
Melissa, how do I set this up to do Pythagorean theorem?
4 squared plus 4 squared.
I'm sorry, there are people being rude right now. We're going to wait for them. All right. How do I set it up, Melissa?
You can do 4 squared plus...
Time out for a second, guys. When someone starts talking, don't start your own conversation, please. We're here. We're talking about this right now. Phones need to be put away. I see several of them out right now. Put them away. Sorry, Melissa. Third time's the charm. Please explain to us how you use Pythagorean theorem.
You would put 4 squared plus 3 squared equals c squared.
So off the side, I'm using 4 squared plus 3 squared is equal to c squared. Where did you get 4 and 3 from?
From the left, yeah.
Okay, the sides. So if I, let's say, start at 2, 3, am I going up or down or left, right?
You're right.
Okay, where am I stopping at?
Where the other point is now on that one. Right there.
Right there? Okay. And then what's the other side?
Go up 3.
Go up 3.
Hey, whenever it's a coordinate plane, is it like, do we always count the squares as like inches or?
Not inches, just units. It's just those squares. All right, so that's where you get your 4 and your 3 from. Thank you. So when I square those numbers, what am I going to get? 4 squared is?
25. 5.
4 squared is?
16 plus 9 equals c squared.
Okay. Let's keep on going. Melissa, when I add those two numbers together, what do I get?
25.
25. And how, am I done right there?
No, you take the square root, you get 5.
Okay, take the square root, and you should get length of 5. Good. All right. Somebody else, raise my hand. What is another method I could have used to get the same length?
Distance formula.
Okay, so we're going to walk through the distance formula. Okay, so what 2 points am I looking at again, Riley?
6, 6, and 2, 3.
So I'm looking at 6, 6, and 2, 3. So when I plug this into my distance formula, what's going to go in this very first parenthesis?
2 minus 6.
2 minus 6 squared
Plus 3 minus 6 squared.
Okay. 2 minus 6 is going to give me what? What is it? Negative 4. Still squaring. What's 3 minus 6? Negative 3. Okay. Bless you. As we've talked in the past about when we're using the distance formula, Riley, is it going to make a difference whether or not these two numbers are positive or negative?
No.
Why not?
Because when you square them, it's a negative times a negative.
2 negative equals.
Okay, very good. Good to build off that. So, much like in Pythagorean theorem, you're still using those two numbers, 4 and 3. 4 squared again is what, Riley?
16.
Plus
9.
So overall, underneath the radical sign is going to be the number
25.
And so my distance is still
5.
5.
And you know what I would do to get like if it's what if it's a negative number? Like a negative number and you put it down there?
Here. Where are you asking me? Okay. All right. So those are the two methods. Those are the two methods that are very popular to find the length of a segment when we're talking about a coordinate plane. It is those two methods that you need to be familiar with when we're getting into today's content. Show of hands, how many of you guys prefer the Pythagorean theorem? How many of you guys prefer the distance formula? Okay, it's your preference. Obviously, it's not going to make a difference. You're still going to end up with that same length. But you need to have an understanding of both of them to do what we're doing today. So we're getting into equations of circles today. So on your table, you should have 3 packets, one for each of you, one for each person in the group, labeled equations of circles. And it should have that circle right there, that big circle, on a coordinate graph. All right. All right. So everyone should have this up right now. We got a couple things we're going to fill in first as a group. The first thing we have is called the origin. Melissa, what do we call the origin? The point 0, 0. Sorry, trying to connect this right now. Okay, so your origin is the point 0, 0. So if I mark that here in my circle, what is another name that we have for that point relative to the whole circle? The center point. That origin is known as your center point. What is the radius of my circle going to be? 5. Okay, so Sarah just said half the diameter. So what is the radius going to be, Sarah? Sarah? 5. Okay. How did you know that the radius was going to be 5? Half from the center. Do you want to phone a friend?
Yeah.
All right, pass it off to someone who has their hands up. Pass it off to someone.
Okay, we count 5 points to any of the sides, up, down, left, or right, and it's 5.
It's going to be 5. Where are we counting it from? The very center. So give me one of those points that you could count from, Riley. From the center to
0, 5.
0, 5. So you just went ahead and went up. Okay? So that is one of those points. There are 3 more really easy ones to identify that you could just do the same thing for. Allison, what's another one?
From the left.
From the left.
Oh wait, here. Okay, wait. Negative 5, 0.
Negative 5, 0. Okay, so there's another one. Matthew, give me a third one.
Just 5, 0.
5, 0. So going off to the right there. And then, Mariah, what's going to be that last one?
That would be 0, -5.
0, -5. All right. So, those are 4 really easy points to see, as you guys have already pointed out, by counting to them. Are there more than just those 4 points on this circle? Yes, there are. I'll give you an example right now.
Here, I got one.
The point 3, 4 is one of them. In your groups, what I want you guys to do is look at this graph, look at the circle on the graph, and see exactly how many points, how many coordinate points are on the circle. And list them. So as a group, discuss how many points can you find how many coordinate points,
Other ones?
and then label them.
Like all the other ones were there?
I can't tell if I got through all of them.
So like all this thing.
Yes. So, for example, 24 was one I just gave me. What's another one over here that I can give you? That you can have?
5, 1.
Okay. Okay. So label those points, and then do that all the way around the circle. How many exact coordinate points can I plot on the script? Is 12 including these 4 or not?
You just saw the points that were his, and they're gonna play pieces.
So,
How many did you find?
each of these points.
I know. I'm sad.
One of those points down to
I feel like it's bad employees. But look, there's nothing.
because you can't. And you probably
It's confusing.
Can I count the members? I could count it out. So you have to use one of those two.
Yeah.
4, 5, 6, 7.
I got 12.
Yeah.
Yes.
Wow.
I'll give you guys about another minute. Well, actually, we're going to go. Okay, guys. I know the time frame's a little funky today, so listen up. I need you guys to listen up. Go ahead and generate ideas and think about what points are going to be on this circle before you go to lunch today. When we get back from lunch, we're going to discuss all the possible points as a group, and then we're going to move on. So when we come back from lunch, get right back in your seats, get ready to go.
It's right. I got it right. It's wrong at the center. Are you so you're serious? Yes. I'm sorry, I didn't know that.
So it's 12, it's 11:30. 12:30, 12:55. If you were the first one back for your group, you should already be signing in and going to the link that was in the Chromebook when you were coming back. If you are not, it's time for you to look up here. Let's go ahead and talk about the points on the circle, which we left off with before we went to lunch. So, Sarah, give me one other point that you found on the circle. -3, 4. Okay. Destiny, give me another point, please. We already have -3, 4.
Dang it. Hold up. -3, -4.
Okay, so -3, -4. Melissa, thank you for raising your hand. Name me another point.
3, -4.
3, -4. Okay. Cody, give me a -4 and 3. -4, 3. Make that a little bit better. Catherine, give me another one.
4.
4 and +3. Lance?
4 -3.
4 and -3. Then give me the last one.
-4, -3.
-4 and -3. All right, so all of these are the possible points that are on your circle, including the original 4 in blue that we talked about. How many points in all do I have? 12 points. So you should have 12 coordinate points. No matter if I'm going from the center to one of these on the y or x-axis, or if I'm going from the center to one of these points, what is always going to be that distance?
What if it doesn't look like that? What if it doesn't look like it's like
If it doesn't look like a what?
See, like 4 -3. That kind of looks a little off.
4 -3.
Yeah, it doesn't look like it's like right on the point.
That one is going to be directly on the point. It is a little bit difficult to see. I can give you on this because it can be a little bit blurry, but it is directly on that intersection. All right, so Melissa, what was the distance? Oh, I'm sorry. What is it? 5. All right, guys. Why do I always know it's going to be 5?
Does the matter?
Say that again. It's always going to be 5, right? What's one, Melissa? One of our methods that we could prove that. Okay, Pythagorean theorem. All right, what's the second one? Okay, so we're not going to do those because of time-wise right now, but we could prove that any of these points on the circle has a distance of 5 between that itself and the center by using those two methods. What I want you guys to do now is go ahead in your packet, flip over to the second page where you are given 2 tables, and on your Chromebooks you should be at this page, Open Math Reference. Position where everyone in your group can see the screen, because you're going to talk about this as a group. You should have this screen right here, little box with a circle in it. Down here at the bottom in the gray toolbar, hit full screen. Hit the full screen.
Wow.
All right.
I can't see it.
All right. So what you're going to do is you are actually going to follow on your table the center points in the radius, and you're going to manipulate this circle on the graph. So this is how you do that. This very middle point, what do we call that again? Center. The center point. I'm going to take that point and I'm going to move it around. I can move it and change my center point. What's my first center point that I'm going to change it to?
0, 0.
0, 0. Okay? And it's even going to tell you that right there, so you can actually see the numbers move as you are moving it around. The second thing that you're going to change throughout this whole activity is the radius. You do that by clicking the point on the outside of the circle, and you can make it bigger, you can make it smaller. So, looking at our table, Mahoney, our center is going to be 0, 0. What's going to be my first radius? 10. So I'm going to move this out to 10. In the top right corner is the equation of that circle. You're going to jot this down. You're going to copy it down and put it in the table where it says equation. So in the top right corner, in blue, the equation, too small to see it on this board, so that's why you have the Chromebooks. Write down, copy down that equation. For this first table, I'm going to give you guys 2 minutes. 2 minutes. Move your circle around, change the radius as is directed by the table. Fill in the equations for each one of those for the first table only.
The radius is already done.
What did you do now? How did you?
You can't, it wasn't completely. It's working.
Go to full screen.
What do you mean? That's you double little me. What do you mean?
Yeah, and then the square root. And you mess me up.
It's equal to the same thing.
Right, is there any, does the radius change? Is there, what makes you say that? Different radius, what do you think is going to change in that? What part of the equation? Okay, go ahead and start that one and see what you find.
0, 0, radius of 7.
8, 9.
All right, 30 seconds. Gave you a little bit more time than I wanted to, but 30 seconds.
Okay, copy that.
Come on.
First table. Very first table. Austin, give me the very first equation.
The very first equation.
Very first one.
Table.
Yes. Guys, listen up. Shh.
It's going to be x minus 0, but like in parentheses.
Okay.
Squared to the 2.
Hey guys. One of your classmates is talking right now. Please be respectful. Check your answer. Continue, Austin.
Y minus 0 in parentheses squared equals 100.0.
Or just 100. Okay, good. Cameron, give me the second one.
Parentheses, x minus 3 squared plus y minus 2 squared equals 100.
Maddie, give me the third one.
X minus 8 in parentheses with the 200 and then plus y minus 9 square root of 2 equals 100.
Okay. Now, let's talk about this. You had a question at the very bottom that asks you, how do you think that the center point is significant, typo, should be, to the equation of the circle? So how do you think the center of the circle is going to be significant to finding the equation? Who's got an answer for me? Let's get someone I haven't heard from you. Destiny, do you have an answer?
It's used in the distance formula.
Okay, it is used in the distance formula. How so?
Because of the coordinate points.
Because of the coordinate points? Okay. Who can help her out?
Because that's the exact formula. Yeah, but
You have the same radius.
Okay. Appreciate the. Maddie, what'd you say?
it's the same equation for it.
As what?
The distance formula.
As the distance formula, right. It is the same as the distance formula. As I went from first equation to the second equation to the third equation, looking at my criteria by which I made my circle, what was the only thing that changed?
The numbers. The center.
The center point.
Oh.
Okay? Looking at the equations, when I went from one to the next, to the third and final one, what is the only thing that is changing, David, every single time?
What you're subtracting from x and y.
What you're subtracting from x and y. the numbers that I'm subtracting from x and y, what do I notice about those in relation to my center points? Say that louder. It's the same as the coordinates. So if we had to take a guess about how the center point is going to relate to our equation, what do you think we're going to say? Riley, what do you think?
The x point goes into the first parentheses and the y point goes into the second.
Very good. Very good. If you haven't done so already, go ahead and start on the second table now. I'm going to give you guys another 2 minutes to do that. 2 minutes to do the second table. If you finish up early, go ahead and answer the next question as a group at the bottom. How do you think the center point is and then discuss what you think the equation is, and we'll talk about the last question. What's my center point here?
I thought you put 4.
Yeah.
This is just so I don't lose weight.
So then discuss as a group the last question. How do you think the radius is?
You know what that means, right?
There's that.
Radius 8.
Okay, let's change the sum of the equation. What do you notice about the radius and the actual?
Everything's the same except for it's 49.
These are the same as the coordinates.
It's a multiple of it. If I look at 7 and 49, what can I say about this two?
You gotta read the last one.
So this number is always going to be, what do you think?
32.
Not the square root. Something?
Mahoney.
You have it. You have all the pieces there. Put it.
Wouldn't it be the same reason?
Okay. Right. But here we're talking about the radius. How's the radius related to the equation? How's that significant? So the square root of 7 is 49.
Daddy order.
Ooh, 7 times 7.
Yeah, that's what I was trying to do.
Oh, okay.
Oh, yeah, 8 times. Wait, 8 times 8 is 400.
No, so this is 8.
Big difference. It's going to be x minus 3 squared plus y minus 2 squared equals 124.
Okay. Let's go ahead and fill out the second table. Allison, give me the first equation for the second table.
X minus 0 in parentheses to the second power plus y minus 0 in parentheses to the second power equals 49.0.
Okay, or just
49.
okay, or just 49. Camille, give me the second one.
X minus 0 plus y minus 0 to the power equal to 6.
Okay.
Is it like that number? The radius times the radius?
Okay. Austin's on the observation right now. What are you talking about the radius times the radius? What part of the equation is that going to be?
That would be the equal.
That's going to be whatever it's equal
The
to.
answer.
Right. So let's talk about real quickly as a class. The only thing I'm changing in my criteria for my circle as I go from the first one to the second one is what? What's the only thing changing?
The answer.
The end part.
Nope.
Oh, radius.
The radius. Looking at my equations now. Going from the first equation to the second one. Kayla, what's the only thing that's changing?
The sum.
The sum? The answer at the end here. Correct. Look at each of those numbers on the very end of your equation, the numbers that they're equal to, and the radius. So looking at the first one, the numbers 7 and 49. What's the relationship between those two numbers?
7 squared is 49.
7 squared is 49. What about 8 and 64? 8 squared is 64. So let's see if that holds for the rest of our answers here. This is going to be, Andrew, what's going to be this third one?
That is x minus 3 squared plus y minus 2 squared. 64.
It's equal to 64. And then, Torres, give me the last one.
X minus 3 squared plus y minus 2 squared equals 144.
It's equal to 144.
0.0.
0.0. So, if I had to say what the significance of the radius is to the equation, what would I say? The bell might ring in a minute, but we're not leaving until we talk about this.
I don't know what it's called. When you multiply it by itself.
Who can help her out? Multiply it by itself.
If you square the radius, it's the answer to the...
Very good. You square the radius, and that's going to be the number that you set the whole equation equal to. Even if the bell rings, I need you guys to listen up. Please don't start moving. Please don't do anything, because we have about a minute left. Please keep these packets for tomorrow. We're going to revisit this tomorrow. We're going to finish it up. If you have a Chromebook, which everyone should, I need one person per group to bring that Chromebook back over here to the cart, making sure it's plugged in. So go ahead and do that now. I need all those.
There's things that can help you that can help you. Lower.
You know what else you missed?
Huh? No.
Are you recording right now?
I don't know. This is one and done.
Oh.
What it is? Yeah, you showed me it on Monday.
I just feel so
I don't know what to write. I said.
Yeah.
This is going on YouTube.
Are we not?
It's called Oz TV.
You have to say
I don't know what he said.
I'm not allowed to be recorded. For real, like my mom.
Took you a while to understand. I love how we're so I know, right? I don't know what I'm and then look at the Cheetos. Do this. Maddie, not oh, what about our homework? Really nice. I don't know what I'm getting the other.
What'd you say? What about our what?
Yesterday, you should have done it.
I did do it. What are you talking about?
I did it too.
Oh, well, that's what I really saw one myself. She just said I'm a new kid. Because I told myself. Yes, you told me something.
So what is that?
I don't know how. Because they
Shoot.
Ah, shoot. Ah.
I It said that all my friends all of our friends.
That's mine, bro. Why are you
I wasn't here. I don't know.
Number 2, she didn't have the most
I want to run the answer song. I don't have to take the mic. What, how to sit up?
I'm a very simple person.
Who is this again? Fathers only Christian leaders.
Riley.
Grinder.
Riley. I don't watch on TV. No,
Riley.
heard of you. I need you to get on your phone and stop talking except
When I get done with the government, can I get my phone?
When we're done with the work, we have some individual work.
I'm not calling.
I play my own.
All right. So, going off of what we talked about yesterday, we did an activity as a class where we were exploring the equations of a circle and how the two pieces of information, the center and the radius, how those actually take a role when in the equation itself, how it helps us write the equation itself. So, as an example, if I were to give you the equation x minus 0 squared plus y minus 0 squared is equal to 100. All right. Melissa, you said 0, 0. What does that represent?
The numbers in the equations,
The numbers in the equation. What do you mean by the numbers? There's a couple numbers there.
like the y value.
The y value?
Yeah.
So just the y value?
Or you can look at like.
I think you're talking about two different things here. I think you're on the right track, but let's see if we can get somebody to help you out. Maddie, what do you think?
It's the coordinates, the x and y on the grid.
Okay, so we're talking about the x and the y coordinates. What two numbers in our equation represent the x and y coordinates?
The zero.
The zeros. And that's representing which of these two things?
The center point.
Center point. So your center point is going to be 0, 0. What about the radius?
Multiply.
10. No, it's 0. The radius is 0, right?
It can be squared. too.
Riley.
Oh, the radius is 100. It's the square root of 100.
Okay.
The radius squared is 100.
So what is my radius therefore going to be?
10.
10. All right. So if I had to think back to yesterday and make a rule about writing equations, what are going to be the, how can we determine what the numbers are going on x and y? So, repeat the question a little bit better. If I'm given the equation of a circle between these two pieces of information, a center and a radius, how do I know what numbers are going to go on my x and y's? Maddie, say that last bit again.
It's the center.
It's the center point, right. What about the radius? If I had to make a rule about the radius, how does the radius play into my equation? Riley,
Radius squared
is going to be what?
equal to, how do you say that? Like, what do you call
Just
it?
whatever the number it's equal.
Okay, it's also.
So it's going to be the radius squared. So let's do an example together. If
Did we do this on the bell ring?
yes. Okay. So if you're given a problem such as this that says, here's the center point and here's the radius, and it asks you to find the equation of the circle, how do we write that out? Maddie, give me the very first term there.
X minus 4
Okay, x minus 4, and what's going to be on that?
with the 2.
Okay, somebody else, give me the second term. Maddie.
You said Maddie one.
Nah, sorry. Melissa.
Y minus 6.
Y minus 6. And what's on y minus 6? Squared. All right? Who can help me get the very last one? What the number it's going to be equal to? Someone I haven't heard from. Lance.
Oh no, 49.
It's going to be 49. And how'd you get 49?
Oh, 7 squared.
7 squared. So your equation for a circle with the center point 4, 6 and a radius of 7 is going to be x minus 4 squared plus y minus 6 squared is equal to 49. So, real quickly from yesterday, if you haven't gotten it out, go ahead and get the packet out from yesterday. We're going to continue on with that.
For Mr. Mahoney? Oh, okay. Okay. All right, bye. Are you doing leadership luncheon?
Yes, he's not doing Okay.
So you need to be going. You need to go to that. Like,
Directly after this? All right, so on your packet from yesterday,
They only lost this package.
all right, on your packet from yesterday, you should be on the third page. Third page, the equation of a circle. So, the standard equation for a circle, we're finishing this up from yesterday, is x minus h squared plus y minus k squared is equal to r squared. So that's the standard equation. That's how it's just written as a rule. Where blank is the center of the circle and blank is the radius. So the center point is going to be a coordinate point. What two variables are going to make up my center point? Melissa? HK. What variable is going to represent my radius? What variable is going to make up my radius, Matthew? R squared?
Just R. Or just R.
Just R. Because this is saying what? What am I doing to the radius? In the equation itself. The radius is just represented by just the R. All right. At the very bottom of that page, you should have a couple examples. The first one is where you're actually given a picture of a circle. So, what two pieces of information do I need when I'm writing an equation of a circle? What was it? Center point and the radius. All right, Mariah, what is going to be my center point for this circle? 0, 0. Pretty easy to see. 0, 0. Torres, what's going to be my radius? You can look also on your papers. The radius of this circle. What is it?
You said 2.
Okay. Okay.
All right.
Guys, radius is going to be 2. All right. So if I were to write out my equation, the first term, Allison, what's going to be in my first parenthesis? Hey guys. Matthew, over out.
X1 is 0 in parentheses.
And what's on that?
Squared.
Okay. Now, Lance, what's going to be on the second term? Or the second parentheses, rather.
Y minus 0 squared.
Y minus 0 squared is equal to, let me get somebody I haven't heard from today. Go for it. 4. So the equation of your circle here,
Not 4 squared.
no. Why is it not 4 squared? Just the radius itself squared. Radius is already 2. All right. So take a few minutes. I'm going to give you, let's say, we'll do 3 minutes. Right? For each one of these 3, write the equation of that circle. You're given the center point and the radius. Yes.
This is different.
It's different.
So, you're going to do
Almost close.
like you. That was I'm sorry. What? Look at me, man. Do some same time. You're a best person. You can still can't like read anything. Like 3 options. You can, but there are 3 choices. I feel like 3 fingers was 6. Yeah,
How many fingers?
Well, I know this one's that one out.
Isn't this just the Italian thing? Yeah. I don't know. It's like that time where, like, if you looked at someone while they were doing that move, like, you got them glasses. Oh, it's I could probably tell this how. Yes! I'm here for lunch. So bad.
Number 1, solving for an equation, or writing an equation for a circle, rather. Jalen, what's going to be my equation for number 1?
It'll be x minus 2
Okay?
plus y minus 2 minus equals 36.
Equals 36. Very good. Matthew, give me the second one.
X plus 1 squared plus y minus 3 squared
Okay, now, real quickly, a lot of y'all, I'm going to stay on number 2 here for a second. A lot of you guys, I noticed when I came around, you either put it in this form or you didn't. Matthew, why is it x plus 1 in this case? Because I thought it was supposed to be x minus 1.
When it's just subtract by a negative number, it's a double negative.
Fantastic. A lot of you guys, when I was walking around, kept it in that form, x minus negative 1. But as Matthew just pointed out, when I subtract a negative, that sign becomes what? Positive, right. All right. So, last one, number 3. Allison, haven't heard from you yet. Guys, listen up.
X plus 6 squared plus y.
God, hold on a second. People are being very rude right now.
Austin, turn around.
I'm showing you. Everything's my fault.
All right, continue on, Allison.
Y plus 4 squared equals 9.
Very good. If you get in the mindset of that, when you have a negative value on your x or y for your center point, you can automatically go ahead and put x plus that number or y plus that number. What I would suggest to you first is to write it out all the way first. So x minus negative 1 like in number 2. Because if you do that first, then you don't overlook it and you don't make a silly mistake. I know there's going to be people when we come to this test on Friday for questions like this. If you get one where you have one negative or both of them, I know there's going to be somebody who still says x minus 6 and x minus 4. And while you won't have all the points taken off for it, it's a silly little mistake to get anything taken off for you to lose points. Just a suggestion. Any questions over the equations of circles, either these particular examples or anything that we've talked about? Okay then, so before we go to lunch today, before we head to lunch, each of you picked up one of these review packets for Chapter 10. This is for our test on Friday. This is what you're going to start working on. All right? So go ahead and begin working through this, especially looking for those problems that you're still not 100% confident on yet. Please take this time to do that.
Let's get rolling. Can I do my...